Hello, everybody. Welcome back to Planet X News. And we are going to have a presentation today. We're going to be talking about the auroras and also the incoming geomagnetic storm. I have my friend Chris Potter, and we also have our rogue physicist. We're going to be going over a report that she has detailing on the causes of these auroras. And ladies and gentlemen, the reason why we're bringing up these auroras, even though they're very, very beautiful to look at, they are now being seen all over the world, which is kind of unusual, especially if you live in, say, for instance, the state of Colorado and the state of Arizona and the state of Texas. It's very, very rare that these aurora make their way all the way to these states. And we're also seeing the southern aurora, which I actually didn't even know existed. And we're going to be going over some information on these aurora, or are they called aurorae?
Scott, you can say it in two ways. You can say aurorae or aurorae.
Well,
That's
what
right.
the hell?
Yeah, I didn't know until yesterday myself.
So it's like either like potato or potato.
Exactly.
Okay.
Totally.
Well, so everyone, how are you all doing?
Good. How are you?
I'm well, thank you, Scott. And you?
Well, I'm just peachy.
Good.
Okay. I am going to pull up that report, and we're also going to be taking a look at some SDO footage because I believe we're under what spaceweather.com and NOAA is referring to as kind of a watch for this geomagnetic storm. We're looking at some M-class flares, some possible X-class flares, and we're going to be getting into all of that information relatively shortly. Does that even make sense? Relatively shortly.
Yeah, you're good.
I think I might have just sipped a little too much Red Bull. I'm on my second one.
Ah.
But anyhow, anywho, and anyway, I'm going to go ahead and pull this report up, ladies and gentlemen, and we're going to start taking a look at this beautiful, colorful report on the aurorae. We're going to have a soiree over the aurorae.
Yes.
And what causes them. And these are the thoughts of our physicist. So, Doctor, I'm going to turn it over to you. Now, everybody can see my screen. It looks real good, and we're ready to rock and roll. Now, I've been hearing from a lot of the viewers and subscribers that they are seeing these aurora or aurorae as far south as Arizona and Texas.
Yes.
And that's absolutely amazing. I've never heard of that before. I don't know if that's happened many, many times in the past. But what we're looking at here on the screen, this is the aurora that was seen in New Zealand. Now, we know New Zealand's pretty far down there in the southern hemisphere, but I never knew that they actually had the southern aurora. Chris, did you ever hear of the southern aurora? I've never heard of it.
So I didn't know that the word aurorae or aurora australis existed until last night.
I found out about it last week whenever I was reading the report, and I'm like, wait a minute. There is aurora that occurs in, the South Pole?
Yeah,
Wow,
I didn't know. It's really cool.
Yeah, pretty amazing.
Really kind of cool, actually.
So, Doctor, what do you think about this aurorae?
I think they're fascinating. I think they are actually a sign that something is going on that might affect us. And it's beautiful, of course. And so this is what I explain in this report, is how it all happens and what it all means.
Well, I want to hear this because I'm pretty fascinated by this. I've never seen it. I've never seen it with my own eyes, only in pictures. And when you look at the pictures, It's almost like it was airbrushed or, you know, just like painted on a canvas.
Mhm.
And then whenever you get a chance to see the aurora in video, it looks really psychedelic.
That's right.
But I'll go ahead and
Yeah,
turn it over to
it
you.
is. Okay, thank you, Scott. It is quite a light show. And this slideshow is usually visible close to the North and the South Pole. And as we've mentioned, the one at the North Pole is called Aurora Borealis, and the one at close to the South Pole is called Aurora Australis. So, and this is from your own video, which you made, that picture about the Aurora Australis over New Zealand. And it doesn't usually happen so far from the South Pole. The same thing happened during that time for the Aurora Borealis. It came down to much further south than it usually does. And that usually happens because more particles get into the magnetosphere, as I will explain lower down.
Okay.
So if we scroll down a little bit. Okay, so all this comes about because of the particles in the solar wind. And these particles are mainly protons and electrons. There will be some helium nuclei and some other little bit of heavier nuclei in it, but it's mainly protons and electrons. And protons are just hydrogen nuclei. So, but the normal solar wind particles are not energetic enough to give rise to the aurorae. We need something more. We need something like solar flares, CMEs, or coronal mass ejections, or the fast solar wind coming from a coronal hole to energize these particles enough so that they can penetrate into the Earth's magnetosphere. So we need to look at what the magnetosphere is like, and we start with that picture there in figure 2. As you can see, this is what it looks like close to the Earth. It's as if there was a bar magnet inside the Earth. And that's exactly the same shape you would expect from a bar magnet. Yes.
Well, that's pretty neat.
And yes. But further out from the Earth, because the Earth keeps being impacted by the solar wind, it distorts this pattern so that we get it's pushed inwards on the sunward side, and it's pushed outwards on the night side of the Earth. So if we look down at the next picture, we'll see what it looks like. It's lovely, though. So this is what it actually looks like. As you can see, it's quite a distorted image of what we saw there. Right, so what we have is solar wind particles on the left coming in and impacting the Earth's magnetosphere. So, and then they come in, and with them comes the sun's magnetic field, which is called the Interplanetary Magnetic Field, or IMF. And so they impact, and then there's a barrier called the bow shock. The bow shock is the point at which the solar wind particles are abruptly slowed down. But when a CME impacts that bow shock, the bow shock gets pushed in towards the Earth, and the whole magnetosphere gets even more compressed. And then between the bow shock and the magnetopause, which is the boundary between the magnetosphere, which is the area, that's right, that's the magnetopause, the area inside where the Earth's magnetic field lines are. So between the two, there's an area called the magnetosheath. And that is where you still have the interplanetary magnetic field, or the sun's magnetic field is still inside there. And the solar particles get in beyond there, but they are much slower now. And then they get deflected around the magnetopause. And this is what happens with normal solar wind. But when we have particles coming in that are energized by, say, a CME, something else happens. So if we scroll down, we can look at the next image that explains all that. Okay, and this is quite a diagram. I had to draw it in different phases. So the first one, so the top diagram on the left, what we see is the sunward part of the Earth's magnetic field lines. And then we see a strong solar magnetic field line. The magnetic field lines from the sun arrive as vertical lines. And there would be another green line, say, behind it, and then another one behind it. But we only look at one of them to see what happens. So as this magnetic field line gets pushed in towards the bow shock, and as it passes the bow shock, it's curved. It becomes curved like that, and sort of follows the same line as the Earth's magnetic field line, and it gets very close to it. And it's because it's got a high magnetic field because of the energy of the particles. Something happens, and that is what's called a magnetic field reconnection. And what happens then is the solar magnetic field line connects with the Earth's magnetic field line, and they open up, as we see in the third image there. So what we then have is a hole in the Earth's magnetosphere. And then particles, the solar wind particles, go right inside there.
So this is all what is encompassed in the performance of these beautiful colors and this array of colors, what we call the aurora.
Yes. Yeah, I mean, this is what leads to it. This is what I'm trying to explain. Yes. Because for you to get to an aurora, the particles have to get in. They don't usually get in with just normal solar wind. So in order to get in, they have to be energetic, and this magnetic reconnection mechanism has to happen. This is the only way they can get inside the magnetosphere. So then we see what happens to the green line, because it's the reconnected magnetic field line, right?
I see. Okay, I'm starting to understand this. This is a lot more complicated than you actually think about it.
That's right, it is. Right. So then you see that the solar wind particles are thrust back beyond the Earth with the magnetic field line as well. In fact, when we watch those models, sometimes we actually see this happening. We see the sun's magnetic field arriving, and then we see magnetic field lines being thrust backwards. And this is what's happening. So that reconnected magnetic field line is now thrust backwards, and then it's stretched even further backwards, and then it starts to pinch in the middle. So they are attracted to each other there, and eventually what happens is there's another reconnection. And that reconnection means it gets split into two. The one closest to the Earth becomes a loop, and then the other one forms another loop, but on the outside. Then the particles that were inside the looped one, close to the Earth, spiral, or they have helical paths around the magnetic field lines, and they move towards the Earth, backwards towards the Earth. So what we see there is the yellow arrow represents these particles moving back towards the Earth.
And then that's where
Now,
we see this, the moving back towards the dark side of the Earth, the nighttime side, and then therefore we see the aurora.
that's right.
Oh.
So, but it's a little bit more complicated than that, because what happens is they go in towards the Earth, and some of them go into the Van Allen belts, which are on the equator. So the equatorial radiation belts, and the inner one takes protons. Protons go in there. And then the outer ones is the electrons. And it's actually the electrons that give us that beautiful light show. So it's the electrons we are interested in. And then some of them will go to the poles. They follow the same spiral path around the field lines, and half of it will go to the North Pole and half of it will go to the South Pole. So if we scroll down a little bit more,
Oh, the Van Allen belt.
that's right. So what we see here is the Van Allen belt. This is the inner one, is the blue one, and that's filled with protons, very high energy protons. Most of them actually come from cosmic radiation, because when the cosmic radiation impacts the atmosphere, neutrons are generated, and these neutrons then decay into protons and electrons, and these decayed protons then go into the inner Van Allen belts, and they can stay there for up to 10 years. So you don't need much to have a very high radiation inside there.
That's pretty amazing. I have to say, you know, like I said, I've never really thought that much about the aurora borealis, but you know, now as you're putting it into a complete scientific analysis, this is pretty difficult stuff.
Yes, it is a bit complicated, actually, what actually happens. The whole process, the magnetic reconnection, you have two magnetic reconnections in order to get the electrons to move back towards the Earth. And yeah, and then some of them will go into these belts, and then the rest will head to the North and the South Pole, and they fill what's called the ovals. The polar oval. So if we scroll down,
I have I have one real quick question about this. Can you explain a little bit more about this Van Allen belt?
Sure.
I've heard a lot about it with space travel and the astronauts and blah blah blah. But what is your knowledge on this Van Allen belt? What exactly is it?
They contain high energy particles, and high energy particles are able to do a lot of damage to the human body and to any electronic devices, because they charge particles. So if they impact into a circuit, they can destroy that circuit. So it's very damaging to spacecraft, and the human body, it just destroys the cells. It's the same. It's the same as being impacted by cosmic radiation. So for the human body to go through one of these belts, basically you come out of the other side with most of your cells damaged, and you probably get cancer.
So how far out is this Van Allen belt? So this basically this encompasses the entire Earth.
Yes, it does. The inner one is between 3 and 5 Earth radii. And the outer one, the electron one, is between 3 and 9 Earth radii. So they are quite far out. They are quite far out. But of course, if you want to send a spacecraft to the moon, you'll have to go through these belts unless you launch it through either the North or the South Pole. Mm.
That's interesting.
And yes, it is. The electron one is not as well. It changes a lot quicker because it responds to what happens with the electrons in the magnetosphere, whilst the inner one, it doesn't change very much. Like I said before, you can have particles in there that have been there for 10 years. So, but it's mainly fed by cosmic radiation, and the Earth doesn't get hit by very much, or is not supposed to, although that, as before, has increased a lot.
Did we lose the doctor?
Yeah, I don't hear.
Oh, these technical problems, I'll tell you. Let me go back up here and let's see what happened to her.
Oh.
There you go.
Did you lose me?
Yes, we did lose you. Oh, bloody hell.
I'm so sorry. I'm back.
Good job, Bob.
Okay, I'm panning back down. Now, as we've gone through the Van Allen belt,
yes,
and we're moving into
the polar ovals.
And this is what we're seeing. This is what literally stretches down, where people can see this in the upper northern hemisphere.
That's right. So this is the north polar oval, and this is where the particles that have gone through the two magnetic field reconnections will head to eventually. There will be one on the North Pole, around the North Pole, and another one around the South Pole. And they are mirror images of each other because the particles are divided equally between the two. And some of them even bounce backwards and forwards between the North and the South Pole, always spiraling around the magnetic field lines. So, of course, if the larger the CME, the more particles will get in. And so if more particles get in, then the ovals get larger. So they'll come down further towards the equator. And that's why then you will get the aurora further down on around both poles. Because
how common
we would have.
I mean, I mean, I've heard about the aurora, you know, throughout my life. Like I said, I've never seen it with my own eyes, but now all of a sudden, over, well, I'd say the last few months, I've just been hearing more and more and more and more about it. You know, in the media with the research that I go through. And then now, you know, with people seeing it so much further south, why do you think people are seeing it more and more further south?
That would mean that the geomagnetic storms are getting stronger than usual. So what we had before was C-class solar flares and a CME associated with it led to a G3 geomagnetic storm, which is much stronger than we would expect. And remember, we talked about this. It came in late because it was being opposed by another stellar wind. And then the two stellar winds were colliding, and that energized the particles in the solar wind even more. So when the CME hit the magnetosphere, it was a lot more energetic than if it had not been opposed. And I think that's what happened. So yeah, that's why then a lot more of the particles were able to get in, because the more energetic the particles are, the more of them will be able to get in through that magnetic field reconnection mechanism.
Well, I'll tell you what. Whatever.
And
Oh, I'm sorry, but with this incoming solar energy now coming from this this large sunspot, they numbered it. I think it's number 2661.
Yes, 2661. That's right. So that is capable of M-class solar flares. And don't forget that the last one was, we had a C-class one. So if the same thing happens now, if it's still being opposed by a stellar wind from another star behind the Earth, it will be strengthened even more. So yeah, then we hope.
I was just checking the solar wind, right before we went on the air, and I mean, it was 345 kilometers per second. I mean, that's some of the lowest solar wind that I've seen. I was looking at the solar wind prediction model and the CME tracker, and just yesterday and the day before, well, the day before, we entered into another stream, and it looked, it looked like it took more than 24 hours for us to get through it. During that period, I was getting reports from all over the world about the loss of cell phone service, problems with the internet, power outages. And then there were some people that were completely without cell phone service. The majority of that had to do with the carrier here in the United States, Sprint. And then I noticed people all over Facebook, all over my Facebook page, my personal page, everybody who had Sprint, Sprint cellular service, they either had nothing at all or sporadic reception with their cell phone. So I guess we could be looking forward to more cell phone service interruptions, more power interruptions.
That's right.
And definitely internet interruptions.
That's for sure, because when we have a geomagnetic storm, what happens is eventually you get currents in the ionosphere, and these currents will then cause currents on the surface of the Earth. So we get power grid interruptions because of surges in the circuits. And then we get the same thing happening inside the Earth, in the core. We get currents in there, which of course cause the magma to rise and so on and move around. So we have then earthquakes and volcanic activity. But it's well known as well that geomagnetic storms disrupt telecommunications and radio frequencies. And of course, they will, affect the microwaves, because they are in that range, in the radio frequency. So we can expect, of course, disruptions whenever we have geomagnetic storms. And with so many stars in the solar system, all these stars are interacting, sending particles backwards and forwards to each other. And so we get a whole lot of interaction between the solar wind particles and these particles. So yes, this is what we can expect. We can expect the geomagnetic storms to, I suppose, get stronger and stronger. And this is what will then happen. But a good sign that it is getting stronger is if the aurora is seen at further and further south, or closer and closer to the equator.
Yeah, because I remember the last time people were reporting that they were seeing the aurora in the state of Colorado and as far as the state of Arizona. I mean, that's pretty far south. I mean, that is the bottom southern part of the United States. I think, I mean, that's pretty amazing. I guess I might have been able to see it, but that just amazes me that is now stretching that far south. Now, one question that I did have. What would the effects be with because we know that the Earth has this crazy wobble going on. What effects would that have on the aurora reaching these southern points in the northern hemisphere? Would that really make any difference or not?
Well, if this happens around the magnetic North Pole and the magnetic South Pole, if the magnetic north has changed its position with respect to geographic positions on the surface of the Earth, then yes, then it will form this oval around the point where the actual geographic north is. So if that's moved, then the ovals will move with it.
Oh boy.
Yes.
Yeah, because I'm still getting a lot of emails from people from all over the world. You know, I went through a lot of the emails, which were, you know, they weren't asking questions, but they were making observations. And the observations, these are people who have lived in the same place for very, very long periods of time. They know their sky. And, you know, they're just coming up with these observations, you know, that are kind of alarming. They're alarming to them. And then when I'm reading them, reading the emails, and, you know, the emails would state, look, Scott, I've been, you know, living in this house for 30 years. I know exactly where the sun should be, you know, during this time of year, during this time of day, you know, the sunrise, the sunset, you know, everything seems to be off. You know, what's the deal? You know, and I mean, it's hard for me because I'm not visualizing it with my own eyes. I'm not standing on their front porch or patio or in their backyard during these times. And I didn't live there for 30 years. So it's hard for me to really, you know, drum up an observation in my own mind of what they're looking at.
Yes.
You know, but I know from what I'm looking at, you know, where I live, I know where the sun sets. And, you know, as of lately, you know, over just the last month, it seems that the sun is setting just before it goes down over the horizon, more towards the north and not directly due west. You know, I know it's not going to be a perfect due west.
Yes.
But where I live, everything is patterned north, south, east, and west.
Yeah.
Everything's in a grid pattern. All the streets, all the highways, everything is north, south, east, and west. So I have a pretty good bead on where due west is.
Yeah.
And, you know, just recently when I was watching it, the sun was going down behind the horizon, going down, completely not being visible anymore. And it wasn't due west. It was faded way over to the right, to the north.
Oh my.
And I'm not the only one, you know, I'm not the only one seeing this and saying this.
That's right.
But I don't know what to say to anybody. I don't know what to say to them because I know I'm seeing the same damn thing.
Yes. Well, the Earth is definitely wobbling. I mean, there are many signs that this is happening. And you know what? It could wobble from one side to the other, from one day to the next. And I think it has to do with the magnetic fields of these objects in the solar system, because we are dealing with brown dwarf stars and they have high magnetic fields. And of course, they're going to affect the Earth's magnetic field and magnetic alignment. And if the North Pole changes its position, then I think what's happening is the geographic north is attached to it, so it will change its position as well. And when that happens, then the Earth aligns itself in a different way, and that's what's causing this wobble. And then the sun will seem to be in a different position to what it was. And it could be that it wobbles in one direction, a little bit in one direction. It doesn't have to be by much. It can be 10 degrees, 5 degrees even, and then you might see a difference. And then the next day, another object comes with a different magnetic field, and now the Earth again tries to align itself, balance itself, and it wobbles in another direction.
Okay, I'm going to make
what
you...
will happen?
Oh, go ahead. I'm sorry.
Sorry. What will happen though is, no matter what, if the magnetic field is not in the right position, then whatever happens, the geographic north, the geographic area on Earth that we call the North Pole will get more sun no matter what, because it will be slightly off where the North Pole is. So it can come either on one side or on the other. Either way, the North Pole will get more sun. So this is why we have such a difference in the temperatures at the North and the South Poles.
Okay, well, now I'm going to make you crazy with my next comment. Last night,
yes,
I walked outside right to my car, and at 9:55 p.m., 9:55 p.m., it was so light outside, I could drive my car without headlights.
Wow.
It was still daylight over through the western side of the hills. It was almost like complete daylight at 9:55, 10 o'clock p.m.
That is interesting. So that could be a couple of things. First of all, it could be a type of aurora that's causing some light to be still in the sky. So it could be that where you are geographically has been moved further towards the north. So the Earth has tilted so that you're more north than you were before. Because don't forget, if you're living in the Arctic Circle, in the summer months, there is no night. You always have sunlight.
Yeah, like in those parts of Alaska. I don't know if I could deal with that, with 6 months of daylight and 6 months of darkness.
Yeah,
I would go. I'd probably. Whew.
Yeah, it's hard, but during winter you have the opposite. You have months when you never see the sun. So so it could be that your geographic position has moved so that it's now in the closer to the Arctic Circle. You know, that not the geographic Arctic Circle, but your position has moved to where the Arctic Circle used to be in relation to the sun, if you know what I mean. So it could be that. And the third possibility is that there is another star in the sky at that time that is illuminating the Earth's atmosphere.
Yeah, I just found it very interesting, you know, because I mean, I know in the summertime months in the northern hemisphere, I mean, yes, it gets dark much later, but you know, usually by 9:30 p.m., you know, it's relatively completely dark. Here we are, the first few days of June. I walk outside, 9:55 p.m., and half the sky is still illuminated.
Yeah.
I mean, it wasn't any kind of colors. It just looked like the blue sky. That's
amazing.
That's what really freaked me out. And then I stood there and just watched it.
Yeah, it's not normal. I actually tend to think that because we have so many brown dwarf stars, and we're getting such red sunsets. I remember that a few months ago, I noticed that in the middle of the night, the sky looked burnt orange where I live. And I knew that was not normal. And the direction where it was in, there were no city lights, so it was not due to city lights. It was actually light in the sky. So to me, that was a star was somewhere out there in space, so that it was illuminating the part of the sky that I could see. And that star must have been emitting a burnt yellow kind of color, because that's the color of the sky. And some people sometimes at sunset or sometimes middle of the night see a reddish color. And I think that could be another one of these stars. When they come by the Earth, they're not as bright as the sun, but they emit some light, enough light to illuminate the Earth's atmosphere dimly. So you would see the different colors. I mean, it was blue. So that would mean
it was baby freaking blue. I mean,
so yeah, that's amazing. That means it was probably a star that was emitting white light.
Yeah, I don't know where it came from, but it really did boggle my mind. And
yeah,
I think about 2 weeks ago, I did a short video because I was out. I think it was close to 9 o'clock, 8:55 p.m. Or I think it was 10 minutes till 9. And I was getting some gas. I was just at a local gas station. And I noticed, I looked this direction I looked this time was due east. I did the video. I did it right from my cell phone and uploaded it straight from my cell phone, straight to YouTube. And I'm like, check this out. Okay, 2 sources of light. Wow. Due west, sun going down, all the way down, and the sky is orange. Okay. Then I look exactly due east, and the sky is freaking baby blue.
Oh my. Yeah, that's definitely another star.
You know, I'm on the East Coast. I'm on the East Coast of the United States. I'm thinking, what the hell is going on here? So what I'm going to do is, depending on the weather, we have some weather conditions rolling through. And if I have a clear night, I'm going to be out there today, and I'm going to videotape this once again.
Yes, good.
And I'm gonna show people. I'll have the time. If I could get a clear night, I'm going to show you that at 10 o'clock, almost 10 o'clock at night, it is still light outside to the point where I can drive my damn car without headlights and see perfectly fine.
Wow.
And the sky is illuminated, and it looks like, it kind of reminded me of early morning sunrise.
Yes.
You know, maybe like that 5 o'clock in the morning, you know, when it's just starting to get light outside and the birds are chirping like crazy. But Chris, are you noticing any of this out on the West Coast where you're at with the differences?
You know, earlier in the year, January, and then in December, I was taking pictures in Half Moon Bay, and we were actually timing the afterglow, and it was almost 2 hours after the sun had gone down, and it just seemed to be a bit excessive. I mean, I even have some pictures posted right here to the left of me, and if you actually look on my channel, there's the background is one of those pictures where it was light and it was almost 10 o'clock at night. So the picture on my YouTube channel, that background,
man. I'm telling you,
that's 10 o'clock at night. So I don't know what to say other than there's a lot of hot debate about the afterglow and 2 light sources. I just find it a little bit unusual, to say the least, that you don't need your friggin' lights at night at 10 o'clock.
Yeah, man, at 10 o'clock, man. I'm telling you, at 10 o'clock at night, I could have drove that direction.
Yeah.
No problem. No problem. No lights, no street lights, no nothing. You know, probably it wouldn't. I mean, it only lasted for about 15 minutes and then it was fade to black.
Mm-hmm.
But I just find the timing in early June, you know, normally we get that situation by the end of August, going into the middle to the end of August up on the East Coast, where, you know, that you could probably say, okay, it's not getting dark till about 9:30, quarter to 10, but we're like 2 months away from that. So that's why I'm saying that this is kind of an unusual situation. Maybe other people aren't that observant of that, but I mean, I'm constantly looking up.
I was going to say one other thing real quick was with my channel last year, because I'm kind of a pattern person, which is really weird. June 6th, 2016, a year ago. No BS. I have the video to prove it and the timestamp. Was it J7409's channel? Oh, she had the weirdest sunset. And then straight through 3 months, every single day, my subs were giving me the crazy coolest pictures, sunsets, sunrises, and all other kinds of cheese sandwiches. So it was significant, the colors, sunset and sunrise, starting on that exact date. So I don't know what that means. Anyway, just want to mention that. But no joke. If you go look for J7409's channel, because I know you could use some of her dialogue for the troll stuff, which I thought was funny. Anyway, yes, I'm pretty sure it's almost the exact day of 6/6/2016. And I'm not trying to be a 666 guy, but you know what I mean? I just find it unusual that I had very, very significant subscriber pictures, and it started with that day, going through the entirety of summer all the way into September, and then when I closed my channel, reopened it 3 months later. So I don't know what that means, but still I think it's significant to notice the amount of light, the coloring, morning and night, and yeah, headlights for that long, that's a bit excessive. Anyway, but that's all I had to say. Go for it.
Okay.
We're on figure 7 now.
Yeah, I was just reading. I was just reading something.
Yeah, no, you're good.
Okay, so shall I go on and explain some more then?
Yes, yes,
what's
absolutely.
happening here? So in this image, what you are seeing is the actual light show, which we call Aurora. And this one is Aurora Borealis. It's around the North Pole. Now, what happens for us to see that light is that the solar particles, the solar wind particles, and we have protons and electrons in them, but the protons create a very faint light show, so we don't usually see it. But the electrons produce this very colorful light show that we see there in the image. And they do this because they eventually impact or have a collision with particles in the Earth's atmosphere. And these particles have electrons in them. They are atoms with electrons. They're not ionized. So when they are impacted by these high energy electrons, they change the energy. They go to a higher energy state. And the higher energy state for an atom is one where its electrons, or its outer electrons mainly, move to a higher energy level. So what we call these atoms is excited. We say they are excited, these atoms. And then eventually they de-excite. That is, they move back down to a lower energy level. And when they do, the electrons move down into lower energy levels and closer to the nucleus. And at the same time they do that, a photon is emitted from that atom. And that photon we see as light. So if its frequency or its wavelength will tell us what light it is. And most of these would be in the visible light range. So that's why they create this colorful show, because our human eyes can detect visible light. And this is how it happens.
Is the Aurora able to be seen from space, like for instance from the International Space Station?
Definitely. You can. It's been photographed from space. Yes, definitely.
Wow, that would be pretty interesting sight to see. This big illuminated neon green and blue and pink crown on the top of the Earth. Pretty interesting.
That's right.
So the same effect that occurs in the northern hemisphere, this also occurs in the southern hemisphere, the South Pole.
Yes, exactly. And you usually get a mirror image of it because the same number of particles end up at both poles or at either pole. So 50% goes to the North Pole, 50% goes to the South Pole. And they populate the ovals. And this is the result. So, and then I just mentioned here that they are beautiful, but it's a sign that we are having a geomagnetic storm. And geomagnetic storms are not just things that are pretty to look at. They actually impact our lives on Earth. They impact communications. They, through magnetic induction, create currents in power grids, which can lead to power grid disruptions, which we all find extremely annoying. And it can create earthquake and volcanic activity, which is actually very dangerous. And to our human brothers and sisters who especially live in areas that are prone to this sort of thing. So it's actually a sign of danger, and that's what I'm getting at.
Yeah, I could see that. It's like the how's the saying go? The wolf in sheep's clothing. Because I've been seeing so much more of the talk of, auroras. Constantly I see this in, the spaceweather.com. And, I check real quick to that site every day, every morning. And, I see they have an Aurora tracker always associated with the geomagnetic storms. And what I'm going to do real quick is let's go ahead and just bring this up. Just give me a second.
I was off by 5 days on my video. I had to go check. It was 6/11 of 2016. Sorry, it bugged me. I had to go find the date. I know I'm kind of weird that way, right? I just had to tell everybody. So anyway, I was checking it out, and it was some really, really crazy sun footage that just makes you wonder, right, as to why the amount of color, the light, how early it is in the morning, how late at night it's been, et cetera, et cetera. Some of what we will say in the community, quote unquote, folks have mentioned, like Scott has. I've had other subscribers say the same, and I don't know I don't know what to tell them. I'll just be like, I don't want to say the obvious, right? But anyway, I just wanted to correct myself there on the dates.
Yes, Chris, but I wouldn't mind saying the obvious. And the obvious is that there has to be another star illuminating the Earth other than the sun. There is no other logical explanation for having two sources of light in the sky. It's got to be another source of light. It's another star.
Well, it sounds better coming from you than I actually, so I'm so glad.
Thanks.
What's cool on that space weather site, I was checking it out too. I believe there's subscribers or people that will log in, or maybe there's another site I found where folks will just submit pictures every day. And there's some amazing auroras. Maybe it's not this one. I think it's spaceweatherlive.com, a little bit different.
Yeah, it's a good site though.
Yeah, I couldn't believe all the auroras. I was so tempted. You know, I don't want to make a video, but I'd be copyright strike left and right. So it's interesting. Again, I'm kind of a pattern guy that the physicist, as well as you, Scott, are bringing up Aurorae. We have had a lot of talk about auroras the last little bit, and this is the best timing possible, I think, for her article. Specifically, what I thought was helpful for me was the electrons and protons, kind of how you explain that part in the presentation. I guess looking at the actual chemicals or elements that are in space and how we're able to detect those scientifically, and how that plays into the phenomenon that we're seeing. It really is a very technical and scientific process, and you broke it down very layman's terms style, which is great. Good job.
Thank you. Thank you.
Yep.
Thanks.
Go for it, Scott.
Yeah, that was, well, I was just going to say the same thing. That that definitely, you know, shed a lot of light, because I mean, I knew that there was a direct correlation with the presence of the aurora and the geomagnetic storms. But you know, delving into the pure scientific reason is pretty interesting. Very, you know, very interesting. We have the spaceweather.com up on the screen right now.
Yeah.
And as I was saying earlier, once again, the solar winds, 335.7 kilometers per second. That's just very low. I mean,
it's very low indeed. And that shows you again, this is probably normal solar wind, but it's being opposed by an opposing solar wind. That's what it tells me, because that speed is way too low.
That was from one of your other presentations that you mentioned that. Didn't you mention something in the millions per second?
Oh yeah, man. Well, millions of miles per hour.
So 335.7 kilometers per second is slow.
Very slow.
Okay. Slow. So again, layman's terms, because I didn't know that. Wow.
It's super slow, man. I mean, for our solar wind, that's very slow.
Yeah,
I mean,
just remember that you both quoted in the millions, and that was, again, I don't know this
in miles miles per hour. This is kilometers per second.
Sorry, I get myself confused. What I was trying to say, what I meant was the rates were far higher than anything I've heard before. And then when you just mentioned the lower, I was like, it caught my ear. So yeah, if you can talk more about that, that's great, both of you.
Okay, so the normal solar wind speed for normal solar wind is about 400 kilometers per second. So when we're going into 335, that's way below the normal solar wind speed.
Okay, so that's a good
that's the way I see it, because there's no point in going into miles per hour if we can, you know.
Yeah, I didn't. That was the wrong terminology. You are so precise that way.
Thank you.
I'm harassing you a little bit, but you have to be, right? In your profession and with your students, you have to be that way. So what are we looking at? What's all that good? The cool.
Now this is the actual solar wind, and as I guide my cursor over it, you can see the graph 372. It's been pretty flat line. There's a very small spike here to 375, but it is pretty much a small spike to 402, but very very flatlined. Everything, even the density.
Yeah, I think this is normal solar wind. We're not getting fast solar wind here. and we're not getting any CMEs or filament eruptions. It's just a normal solar wind, but it's too slow. It's slower than normal. So that shows me the normal solar wind is still being opposed by an opposing solar wind. And that may explain also why we are getting earthquakes and communication problems, because even though this is normal solar wind, because it's being opposed, it's being energized by the opposing solar wind. So when the particles are hitting the Earth's magnetosphere, they're more energetic than normal slow solar wind particles.
Now, I have up on the screen now, this is the sunspot that is, it's going to be dead on Earth facing probably sometime within the next 18 to 24 hours. And this is what they were talking about on space weather. I'm going to go ahead and just zoom that in. So, you know, it doesn't look like much, but there was a whole hell of a lot of activity coming out of this bad boy a few days ago, where, you know, me and the doctor, we were analyzing this, and we were seeing filaments and all kinds of releases of energy that were like 100,000 miles long, just bursting directly out of these sunspots. And they were coming from this little bad boy right here. Not this big one over here. They were coming from this little bad boy.
No way.
Because this big one wasn't even visible on the left side of the sun yet. It was not visible. Everything was coming out of this little teeny tiny little area right here. And it was
the sun even, you know, it's such a complicated thing, man. We see it in these different images. I just can't help but stand in awe of what we're looking at. So those sunspots are active. By the way, Mount Sakurajima in Japan erupted today.
Yeah, I heard about that. Do you have any more information on that? Because I didn't get a chance to find anything out about that.
Tokyo, Mount Sakurajima. It's in the Kawashima Prefecture in southwestern Japan. Erupted Tuesday morning. It was 7:56 a.m. local time. It billowed as high as 3,200 meters into the sky. The weather, and was ejected from 1,117 meter volcano Shawa crater. The agency warned that similar eruptions could occur. The last major eruption occurred May 29th this year, and it was a under level 3 orange alert signifying that the volcano is active and should not be approached. It looks like, in September 2016, a team of experts from Bristol University and Sakurajima Volcano, I'm almost done, Research Center in Japan concluded after studies that the volcano could have a major eruption within the next 30 years. Don't you think? That is one of those volcanoes that I just want to mention that I've kept an eye on. There's a couple other ones that we've been watching pop off multiple times over the last couple of years. So I find it very interesting that he was active today.
Yeah, it's very interesting. I mean, to tell you the truth, a volcanic release is probably a good thing for them in Japan, because they are issuing a pretty wide earthquake watch, and they normally don't. You know, they say earthquake watch. On some of these the scientific sites like NOAA, because they don't want to alarm people. Well, what the hell are you doing then?
Yeah.
Get out of your field of study. If you don't want to get out there and tell the damn truth to people, hey, ladies and gentlemen, listen, this is the situation on the sun. This is the situation that could possibly occur on planet Earth. We have a federal space weather office in Washington, D.C. that I've mentioned before that our taxpayer dollars are paying for, but nobody works there. They don't hold any press conferences. It was an executive order signed by Obama. Well, where the hell are the people that work there? Why are they not holding press conferences? Why are they not warning people of what's happening? We warn people about bad weather. We warn people about rain, snow, ice, sleet, hurricanes, cyclones. Why don't we warn them about what's happening on the sun, which directly affects the Earth? Now I'm starting to get a little uppity.
Yeah, the Space Weather Office. I think that there is kind of a push that's only starting to happen, but I believe that, you know, really that it's only because they need to cover their butts.
Exactly.
They haven't been telling us, so it's a great way to ease us into something potentially. You know what I mean?
It just gets to me because they make a big deal out of this. They sign an executive order.
Totally.
And then you never hear anything from this new federal office agency. It's supposed to be directly coordinated with FEMA. But yet it's been a year and we ain't heard shit from them.
Well, as things continue, they will be working very closely with one another, I can assure you.
Excuse me.
Yeah.
All right there, buddy?
Well, I have up here on the screen.
Okay, yeah, please.
This is from the SDO, and this is showing the two sunspots, or the one big sunspot. It's going to be Earth facing, like I said, probably in about 18 to 24 hours. This is one black and white view of it. It does give you a pretty good, scary, impression of the sunspot. But I also have. Let me get out of this and we'll jump into this one. And this one gives you, I think, what is this, Doc? Is this the positive and negative ends of the sunspot?
Yes, one is positive and one is negative. I'm not sure which is which. But definitely one's positive, one's negative, and the plasma loops will connect from one to the other. They always like that.
That looks really, really big. That whole entire area. You figure the Earth or the sun is what, like 864,000 miles in diameter, and you look at the size between, the yellow and the green. It's a pretty big sunspot, and we could probably be looking forward to a good bit of activity. I also have the current SDO.
So what you have in a sunspot is very intense magnetic field. The magnetic field lines are very close to each other. So that's what we have at the magnetic field lines. And to me, the other day when I was looking at it, I said, my goodness, that thing, it looks like a volcano on the surface of the sun, because it was just ejecting sun flares at quite a rate.
Yeah, we're going to take a little bit of a closer look at this. I'm going to bring up my other program here, because this one video program here, it won't allow me to take closer look. So I'm going to exit out of here for right now and jump back over here. And we're going to bring it right back to here for a second. And I'm going to go ahead and I'm going to prepare this over here real quick. And I was watching a video yesterday about, it was from the Higher Truth channel. And he was talking about a brown dwarf star being in the constellation of Aquarius.
Yes.
And I mean, I really respect the guy. I love his YouTube channel. He's been around for a long time. Very, very intelligent, man. I think he's got to be, in the top 5 of some of the most intelligent people on YouTube delving into this subject matter. And but he did make a statement that I just found I found a little odd, that he said, well, if there was a brown dwarf star right next to the sun, something like, the Earth would be completely destroyed, or life wouldn't exist on Earth, or something to that magnitude. And I just found it was kind of odd coming from him, because we're all researching the same subject matter. This is the first that I've heard about the possibilities of a brown dwarf star in the constellation of Aquarius.
Yeah.
Out as far as Neptune. So, I mean, I don't
Well,
know.
That's where the Planet 9 research is, where they're saying it's behind Neptune or past Neptune, right? With the WISE data for everyone to go through and help the citizen research. So, wow, isn't that an interesting parallel? Just want to throw that in there.
Yeah, that's what I said. I mean, I had, that's the first I've heard of it. You know, I just found that was I didn't think he was, you know, throwing any, you know, nasty remarks at anybody's research or anything.
No, not at all. Yeah, no. I was actually reaffirming that, well, if there's a citizen research project to find Planet 9, the inference is that it's behind or past Neptune. So
yeah,
I just think that's really interesting that you said that. And I was talking with the doctor yesterday about his exact video.
Yeah. Okay, so what I think of that is it's the basic indoctrination that every scientist gets when you go through university. And the basic indoctrination is all about the fields around objects. And we know about the electric field, we know about the magnetic field, but what we really get taught about is the gravitational field. And every single astronomer and every single astrophysicist and every single student gets to understand what the gravitational field is. That this is what actually we study the most and what is used the most to calculate different things. For example, we even use Kepler's third law, which is based on the gravitational field, to calculate orbits of objects and their periods. But there's nothing wrong with that. The gravitational theory gives us great results. But the thing is, people are so indoctrinated with it that when they see an observation that does not fit with their theory, they decide that the observation is wrong. So what we have here is a whole lot of observations that I have been making, that we all have been making. Scott has taken pictures of these objects around the sun. And what are we going to do? It doesn't fit our theory of the gravitational theory. I mean, if we had a huge or a couple of huge stars next to the sun, wouldn't that impact the whole solar system? Well, according to the gravitational theory, there would be certain effects, yes. But what else? I mean, my own investigation has led me to the conclusion that these objects are not nearly as massive as the sun. These are actually quite small, like Jupiter-sized, and their masses are more like less than 100 times the mass of Jupiter. So that's still a lot less massive than the sun. So gravitationally, they might impact, but not that much. But what I've also discovered is, by studying these stars, is that they do not obey the normal laws that we've associated with planetary systems and the universe, which is all about the gravitational theory. No, they obey what seems to be a strong force. They attracted to each other, and they accumulate at the center of the solar system around the sun, just like protons in the nucleus. And then I actually get to the conclusion that these objects produce a gravitational field which is associated with their electrical potential energy. Why didn't we ever notice this before? Because we live within the electrical potential energy of the sun and what it creates. And it would have been constant in the solar system, and all the planets would have been in it. So we would think we were living in a universe where the gravitational field never varies, because what we have is generated by the sun. But when other stars come in and we start studying them, we realize, but wait a minute, these stars are producing gravitational fields that are not dependent on the amount of matter they have, but on their energy, on their internal electric potential energy. So that, you see, our observation has led me to realize that the laws we have regarding gravitation are not correct. Gravitation is still a great model to use to figure out interactions and relationships between objects, but it's not what's powering them. So, for example, if we think there's a black hole somewhere in the universe because of how objects are moving around it, well, it's not necessarily a black hole. It's probably an object with an extremely intense electric potential energy that is generating a huge gravitational field. It doesn't have to be a black hole. And that's what I've discovered. But if people are indoctrinated, I mean, I went through the same indoctrination. I studied all the same courses, but I had to move out of it. So that's what I would have to say about it. I mean, I don't think he's wrong in what he's saying. He's using his own understanding. And I must say, I probably would have said the same thing a couple of months ago, because I believe the same thing. But now I have to say that I have to go with the observations that I have made in the solar system, and it changes everything.
It most definitely does. There's no doubt about that. I've pulled up the sun. I put it in my other video program so we can take a look at what's actually occurring. And this is the latest SDO footage of this big bad sunspot that's going to be Earth facing. Like I said, probably in the next 18 to 24 hours, maybe less than that, 12 hours. It's a monster.
It is. And the fact that it's going to be capable of M-class flares is quite sobering. Because with the opposing stellar wind, that could impact Earth extremely negatively, let's say. We could have a lot of earthquakes, a lot more volcanoes, and we're already having them.
Okay, you know, Doctor, somebody had a question in the chat. Remember, what was it, about 2 weeks ago, whenever the moon passed real quick in front of the SDO satellite? What are your thoughts on that?
Well, that's definitely a possibility that the moon passed in front of the SDO satellite, or the SDO satellite just went behind the moon for a little while. It's definitely a possibility. It did look like the moon. I didn't think it was.
Yeah, because I mean, I pulled it up. I mean, I pulled all the information up on you know, Solar System Scope and the positioning of the SDO, and it was dead on. Dead on. I mean, that happens.
It does.
I mean, it does happen. You know, somebody just had a question about it, and I guess they didn't believe me in the report that I gave, because I started getting a barrage of emails. I mean, they were coming in 10 emails a second. They were coming in from all over the world. I didn't want anybody to panic, so I just looked into it real quick. I've seen it before. I've seen the moon pass in front of the SDO like that, but now we're not talking about the SDO eclipse season. But we were just talking about an instance where the moon passed in front of the camera.
That's right. Now, I think the NASA is to blame for people's panic about anything like that, because they've been lying so much that now people don't believe a word they say.
Oh, I'm sorry. I might have misjudged the question.
Mm.
This might have been referring to the 2007.
Oh.
Yeah.
Oh, the 2007. Oh, they
Yeah, when
still
the
think
moon,
it's the moon.
yeah, when the moon orbited the sun.
Exactly.
Well, it couldn't have been the moon because the object that traversed the sun had light from the corona in front of it. The only way any object can have light from the corona in front of it is if it is in the sun's corona. The moon would never be able to go into the sun's corona. I mean, I especially watched this object very carefully before it traversed the sun, it was at the edge, it's black.
Yeah.
Okay. And the images, I observed the images in the different colors, the blue, the orange, whatever color you look at, when the object is in front of the sun, for example, in that orangey one, there's a red light in front of the object. If it was the moon would have been very close to the camera, very far away from the sun's corona, and it would look perfectly black in front of the sun. Perfectly black. This object was not perfectly black. It was red. It was in the sun's corona. It could not have been the moon.
Oh!
There you
Sorry,
go.
I had to add that.
And then just based on the size of the object, I mean, if you put the moon in front of the sun, it's going to look like a little teeny tiny speck.
Yeah.
I mean, like a grain of sand. I mean, you see the size of Mercury when Mercury traverses across the sun, and excuse me, and we catch it on some satellite footage. Excuse me, and you can barely see Mercury. So what makes you think that you're going to see the moon as this big, huge ball whipping around the sun at that speed? It's just ridiculous. Whenever I got myself into all kinds of trouble by showing that footage from 2007 when it was revealed to me, I didn't expect the barrage of trolling that came after that, because I assumed that, people had seen that before back in 2007. And a New York Times reporter who went by the name of Debbie Blue, she was starting to document things pertaining to Planet X.
Yeah.
And I was privy to some information about her. I'm not going to reveal her real name or who she is, but she is an international reporter for the New York Times. Her name is not Debbie. It's just a name that she chose, like a handle, like a CB handle.
Yeah.
And she started investigating these issues of this Planet X. And she's a very, very smart woman, and she started looking at all of the images that we look at, all of the tools that we use. And this was well before the censoring does now with these images. And she was documenting this, and she also had a website, and she was investigating, and she was putting this stuff up on her website. Her website was constantly being hacked and the video clips removed. So she decided to go one step ahead and go to YouTube back in 2007, 2008. And then she started uploading and creating videos pertaining to what she was seeing. Now these videos could not be removed and hacked off of YouTube. So now the information was out there. And she really didn't have that big of a subscribership back then. And then lo and behold, a few months ago, when I decided to pull up some of her videos and show them to everybody on my YouTube channel, I got an email from an individual that I still don't even know who it is, but this person was kind of working closely with the Debbie Blue channel, this investigative reporter. They had many phone conversations. They had many detailed analysis of what they were looking at. And it might be a possibility that this person was helping the Debbie Blue channel. And then all of a sudden, she just disappeared. Now, she didn't disappear from the face of the earth. She just disappeared from investigating and revealing more and more of this information on Planet X. Now, she still maintains, and I think she wants to keep herself now out of this limelight, as you might want to call it. And the individual that emailed me was the person who was helping her and was communicating with her. And, you know, they revealed who she was.
Yeah.
And I did try to contact her. I did contact her and, you know, sent her a couple of emails and never, ever got a response.
Okay.
And she's still currently writing, you know, doing her job as a journalist, but I don't think she wants any part of this situation anymore. Her channel is still up on YouTube. There has not been anything new uploaded to it for a very long time. I think since 2010.
It's been at least 5 years, yeah.
Yeah. And then we have another lady that goes by the name and the YouTube channel Yellow Rose 4 Texas. Texas. And I remember that once again, you got a mysterious email. Hey, Scott, you should really check this information out.
Yeah.
So I went to the YouTube channel. I watched every single video. It's narrated by what seems like an older woman. It has somewhat of a maybe like a little bit of a spiritual side to it, an alien spiritual side to it as the videos go on and on. But I'll tell you what, went disappearing, went and did a disappearing act also for years. And then just recently, she started uploading a few videos again. I think 1 or 2. You know, so this has been going on for a long time, ladies and gentlemen. People have been popping in and out of the Planet X world, trying to get this information and trying to find it. And early on, I mean, the bottom line was, 10 years ago, if you came out and you started mouthing this information and trying to spread the word, they were going to shut you down. They were going to shut you up. They've already killed 126 scientists and astronomers around the world. I don't care what anybody says. It's fact. They whacked them. They whacked a whole plane load of scientists. But I think now they just can't do that. There's too much information out there. Thanks to people like me and Chris Potter, and now, the doctor. And I'll even give out credit out there to WSO, BP Earthwatch, Pastor Paul Begley, the Higher Truth Channel, Mr. MMBB333, all of these people investigating. Everybody showing proof. Now, once again, just because we don't have a bunch of picture shows to show you every single day, which these photographs are hard to come by, if you're even lucky enough to capture something odd in the sky that you can't explain. A lot of the scientific information and the scientific proof and evidence is staring you right in the face by looking at the sun. Our sun has been acting very erratic. Remember all of the coronal holes? Every 7 days. Every 7 days. Massive, massive coronal holes encompassing a third of the sun. Coronal holes at the north pole of the sun, the southern south pole of the sun. Constantly Earth-facing. Now, all of a sudden, the coronal holes have gotten smaller, almost non-existent. What's happening?
Mm-hmm.
What is happening? We have some of the best evidence there is. There's no doubt about it. We have some of the best evidence there is for the existence of Planet X, as you want to call it.
Yeah.
As a matter of fact, I'm going to go ahead and pull up the solar X-ray real quick. Because even though we're not seeing coronal holes on the SDO footage, we're going to see what is lying underneath this bad boy.
There are definitely coronal holes there. I was just thinking the sun looks much darker than it was a few years ago, so that's why. So again, it covers at least a third of the sun.
So even though we're not seeing these big black coronal holes, you know, believe it or not, when you look at this through the GOES imaging and this X-ray imaging, yeah, look at the top of the sun. It's actually grown larger, shifted a little more to the left, and there is a scar of a coronal hole directly from the north all the way to the south.
That's right.
And you can see the large sunspot.
And there's a cutoff line there.
Yeah, you know, that cutoff line seems to be there now constantly, because I look at this twice a day.
Yeah.
This damn thing is there now constantly. It's not being
removed. On both GOES. Yeah, it's there all the time in the middle there and on the right. Yep.
Yeah. Yep. So I don't know if that's part of the imaging or they are just cutting that baby off, because it looks like they're just cutting it off. It looks like they're cutting it off.
They are. I think they are. They do that on the SDO images often as well. I've caught them throughout the years. Even the 2013 images have cutoff lines in them. And that should, but remember yesterday, Scott, how we saw those green objects in the core image?
Yeah.
Because that's why they cut them off, because these objects are everywhere around the sun. And yeah, that reminds me that the same object that traversed the sun a few days before it approached the sun, it was emitting light on the side facing away from the sun. And that made me realize it was a brown dwarf star. But it's definitely not the moon. The moon would not be emitting light from the side opposite to the sun. It would be reflecting light on the side facing the sun, because it's a moon. So so this object was definitely could not have been the moon. Absolutely not.
Now this is the current Aurora forecast. For the 6th of June, 2017.
There you are. You can see the oval being populated. And then you get, because the aurora can only be seen at night. So it follows the night. Well, the particles come in from the night side. So, plus it's difficult to see the lights during the day.
It's pretty neat, though. I was watching this
Yeah,
this new
nice.
model last week, and
very
you can see how far the Aurora went into the United States. It was all the way down into the mid part of the United States, where the states of Oklahoma and Kansas were.
And
that was clear on this model. And let's see here. And then we have the one from the south.
Oh, yes.
It has to load. And then once that loads, it will go ahead and play. And this is directly over the most suspicious landmass on this planet, the Antarctic.
Yes. Wow.
I really want to know what they're doing down there.
That looks so interesting.
Look how thick it is. Much bigger and thicker, and seems like a lot more energy in the south this time.
That's interesting, because from what I learned, they're supposed to be mirror images of each other, but I don't see that here.
Nope.
Oh, I know why. Because you see, the southern hemisphere is constantly, I mean, this area of the southern hemisphere is constantly in the night, in night time, because it's winter in the southern hemisphere. So it looks like they are at this time getting more of the particles.
Pretty good observation there, Doctor.
Thank you. That's what I'm trying to do.
Yeah, it was pretty interesting, and you could run them both at the same time.
Yeah.
You could see the northern hemisphere here, the southern hemisphere here. And I think everybody will probably be getting a pretty good light show, possibly tonight and for the next, maybe the next week, maybe less.
Yeah.
We'll keep an eye on it, and we'll see what happens. I definitely think that we're going to go through a period of these power outages again, and most definitely the cell phone issues and the internet issues. No doubt about it. There was one other model that I've been taking a look at. I think this is it right here. Was this the electron content? So it doesn't look too bad over the United States. But I know there is one model. I'd have to find it that shows the entire world. And I don't know which one it is because they have so many. I think these are just observations. The magnetometer that goes, there's so much here that is pretty useful. There is one dashboard that is pretty useful. Yeah, we're going to just take a look at this this solar wind predictor because, oops.
Oh, look at that. The Earth is getting hit by something right now.
Yeah, I'm going to go ahead and try to bring this up a little bit. So it's a little bit bigger.
Oh, okay. Let's see. Oh, okay. It's not right now. It's on the 11th.
Yeah, that's what's going to be coming. And that's a direct hit.
Yeah.
That's some pretty good density too. Now you notice how it
yes.
dissipates immediately, and not like the last one. Remember the last one that hit us? It intensified as it went past the Earth, and it was way past the Earth, and it intensified. And
this looks like fast solar wind to me.
Yeah, we're looking right here. Now that's a boom right there. That's a nice direct hit, and that's between the 10th and the 11th. Excuse me.
But,
so it's coming around.
Yeah. This is interesting.
Mm-hmm.
Very.
And today's what? Today's the 6th.
Yeah. Yes, it is. I'm just trying to figure out what this is. Doesn't look like a CME. It's not fast enough to be fast solar wind unless it is fast solar wind. But it looks slow because of its being opposed.
It's very interesting. I was looking at this morning, and I couldn't figure it out where this is coming from.
Yeah, that's what I'm thinking. I mean, it's not fast solar wind because the solar wind speed on the 11th
to show itself around the 8th. If you watch the line, and as it comes out, right there, like around the 7th, the 8th, and then it starts to pick up. And then by the 10th, it seems to pick up speed, and it seems to widen, and bingo. And you don't see it. You don't see it, but I'm going to show you. Let me just stop this for a second. I may even have to zoom into this. But right here, I'm going to have to zoom into this because I want to show you something. I don't know if you could notice, but do you see the difference in color?
Yes, I do.
It's actually turning red.
Ah, yes, I can see a bit of orange in there. You're right.
You can't really see that when you're looking at it, but that is getting way up there as far as the density goes.
Yes.
Who cares about the velocity? That's getting pretty dense, and that is halfway through the day, UTC time on the 11th.
Yeah. Yeah, the particle density goes up there.
Yeah, very suspiciously. That's very odd, if you ask me.
It is very strange.
See, if you watch
You'd expect that from a small CME, perhaps.
And it runs off because we don't have enough data at that point. Now, maybe tomorrow or the next day, we'll see this.
Yeah.
But you can see the expansion. Look at the expansion. And then right there, that density gets really, really thick. I don't even see on the scale. That's like right up above. What is that measurement that they have over here? You're the physicist.
That's plasma density. So that's basically the number of particles per unit volume.
Yeah, so that's not looking good.
No, it's definitely higher than, I mean, I would expect this from a CME, but I haven't heard of any reports.
Me either.
Of a CME.
Me either. Nothing.
So, again, do you know what this is? This is a stealth CME.
So we're looking at it it starts to give birth today, halfway through the day between the 6th and the 7th, moving into the 8th, moving into the 9th, halfway between the 10th and the 11th, and then start to feel the impact on the 11th, halfway through the 11th, going into the 12th. By June 12th, we're going to be dead on getting hit with something.
Oh yes, this is the fast solar wind overtaking the slow solar wind. So this is what you would expect to come out of coronal holes. And then the fast solar wind moves faster than the particles that were ejected first from the slow solar wind. And they catch up, and where they catch up with each other, you get higher density. So that's probably what it is. And that spiral there is where the particles overtake each other. The fast solar particles overtake the slowest, and then it creates this area of higher density that spirals around or outwards from the sun.
Yeah, this is going to be
So
pretty
I think
interesting.
that's what it is. Yeah.
So this is about 5 to 6 days away, but I haven't heard anything about this. Nothing.
Yeah.
And for this to just creep out of nowhere, where's that coming from? I mean, are they do you think they're predicting this from the sunspot, the AR 2661?
Probably. I'm not actually, no, I don't think so, Scott, actually.
Where the hell is this coming from?
I think it's just the fast solar wind particles overtaking the slow solar wind particles. I think that's all it is. And the Earth goes through that spiral where the density is higher at that time. You know, you see it in the larger model diagram. What are they called? Signets.
Let me see if there's a CMA.
You can see that the orange colored spiral.
I was looking for the CME tracker. I'll just go to my trusty BP Earthwatch. Around running through a bunch of government sites. He has everything readily available, which is absolutely perfect. We'll take a look at the CME tracker and see if we, see anything that has been unreported, because I think that's a pretty good hit right there. But I
don't think it's the CME. It's just higher density particles. An area higher density. Yeah.
Yeah, so, okay. So apparently it's not a CME coming our way.
But we might still get one tomorrow. Oh, there's something that left the sun there.
Yeah, on this backside over here. Yeah.
Yeah. That's a CME.
Yeah, that was that big ejection on the 31st through the 1st. That's the one that came out of the left side of the sun. That was pretty big. I saw it on the coronagraph. So yeah, so it looks like we're going to have a little bit of space weather to look forward to over the next couple of days. Oh, probably the next week, I would have to say.
I think so, yes. I agree.
So it should be very, very interesting.
So they did say on spaceweather.com, just regarding the meteor shower that we're going through, that it happens every year in early June, and the resulting Aureatid meteor shower typically peaks on June 7th. If you could turn off the sun, you would see more than 60 meteors per hour. And I'm pretty sure Mr. MBB333 was saying something like 100, 110 an hour, and he's been keeping a real close eye on that. Just, I wanted to mention that because I didn't know about that at all.
Yeah, yeah, I watched that report. He had that report up, and I just caught it. And as a matter of fact, let's pull that damn thing up here real quick because
yeah,
that was kind of odd because I didn't hear anything about no meteor shower or nothing.
Neither at all, nothing. And I just saw that, and I'm like, oh, okay, well, I guess we're going through a meteor shower.
Yeah, because I know he pays close attention to it, and
yeah,
it was raining in. Well, I don't see nothing on there right now. It's actually pretty calm, which is good. Yeah, there's yeah, as of right now, 1900 hours, nothing. Well, that's good. They went through a little debris field of some kind, possibly. I'll have to keep an eye on that. I'm gonna definitely keep an eye on that over the next couple of days, and some other things. So we know we have this sunspot moving towards us, probably, like I said, within the next 12 to 18 hours. We know that we're going to be facing another geomagnetic storm. How powerful it will be, we will have to wait and see. So, ladies and gentlemen, if you happen to have some problems with your cell phone service, internet service, power outages, you know where it's coming from. It's coming directly from our sun, and that is why we pay very, very close attention to what is occurring on the sun, and whether other people out there that are doing their own investigations, if they don't believe that there is anything substellar near our sun, they are more than welcome to their own opinions. But based on what we're observing and based on the research that we've been doing for quite a long period of time now, we are definitely showing solid evidence that we do have these brown dwarfs and probably planets, planetoids, exoplanets, objects that have come in with these brown dwarfs. We definitely have a situation within our inner solar system that we have to keep a very close eye on. We have to stay vigilant and keep up on our research and our investigations on a minute-by-minute basis. That's how fast these situations can change. And once again, we've already seen the considerable increase in the earthquake activity, the volcanic activity, and not even to mention the crazy, wacky weather, which has turned very dangerous. And in the upcoming days and weeks and months in the Northern Hemisphere, I think we're going to see some very tragic situations dealing with weather. I think the hurricane season for the East Coast of the United States is going to be bad. And possibly even the Caribbean and countries like the Dominican Republic, Cuba, and God forbid one of these massive hurricanes gets up in the Gulf of Mexico again and makes a beeline for, the Gulf Coast states. That's the last thing we need is another Katrina. And we know damn well it can happen in a blink of an eye. So, we're going to be paying very, very close attention in the weeks to come. We're going to be paying very close attention to the weather. People say, oh, Scott, shut up, shut up. The weather has nothing to do with Planet X. Well, you're wrong. You're dead wrong. If I had you standing in front of my face, I would say it to your face. You're dead wrong. I think this summer in the Northern Hemisphere I think we're going to see some of the most vicious weather any human being on the face of this earth has ever seen. I hope I'm wrong. I hope I am wrong. We've already seen some very, very, very early cyclones in the South Pacific. Queensland. I mean, that cyclone formed offshore, sat there and spun like a top, barely moved anywhere, and then came in and just drenched Queensland, Australia. I think we're going to be going into some very, very trying times dealing with this weather. And yes, the weather is part of it. I mentioned all of this almost a year ago. I mentioned the possibilities of very severe climate change, very, very severe weather. What did we have this wintertime in the Northern Hemisphere? Crazy weather. Warm on one side, freezing cold on the other. The Southern Hemisphere, the poor people in Australia, they were battered with extreme high heat temperatures all summer. And then to end their summer and go into their change of season, they get crushed by an early what would they call that? An early winter cyclone. It caused a lot of damage, a lot of flooding. What was it last week in Taiwan? It rained 24 inches. 24. Yeah. So yes, weather is part of our Planet X research. Crazy weather is to be expected. Don't let your guard down, people. When people come at you with these idiotic statements, brush them off because they don't know what they're talking about. They haven't done any research. I think we're going to have some very serious weather situations around the world. Well, Doctor, you have one that is knocking on your back door in the next 2 hours.
Indeed. Yes, they're closing down the schools in Cape Town tomorrow because of a severe storm hitting the coast. And 2 days later or 24 hours later, it will start hitting here where I live. And it's going to get bitterly cold.
Yeah, we watched the weather report. We watched the weather report together just a few hours ago. I didn't even hear anything about it. And it's going to be a very, very serious situation. Southern tip of the African continent. I think we're going to be seeing more and more of this crazy weather. And it doesn't matter what part of the world that you're on. I think everyone is going to see some of this craziness, this climate chaos, rogue weather, wacky weather, whatever you want to call it. It does have the potential to cost people lives. We've already seen it. I feel so bad for the people in some parts of Indonesia and some of these other small island countries, and then the people in South America. I mean, I don't even know how many deaths already since the beginning of the year have been directly attributed to weather-related floods, landslides, and just all of this mess. But yet, mainstream media, the only thing they want to report about is what people are doing to Donald Trump and what Donald Trump is doing to them. That's all. That's all I hear. And psyops being conducted over in the UK. Yeah. I think the world has a lot of things going on right now that are a lot more important than Kathy Griffith, whatever the hell her name is. She sucks as a comedian. I can't stand her. Just really blows me away. It blows me away that there is so much going on around the world. And this is all that the corrupt news network, CNN, can talk about. But anything, anything to do with these mainstream medias, oh my God, I can't even watch it. I can't even watch the news anymore. But one thing that I did want to touch on, Chris, you're out on the West Coast. Have you heard of anything going on with the ice melt in the Sierra Nevadas, or any potential weather hazards in your neck of the woods over there? Because I know there can possibly be some really extreme things that occur with that ice melt.
Yeah, it's just been talked about that, the officials are concerned about the rapid amount of ice melt, et cetera, because of the weather and how warm it is, especially around Oroville. They were talking about that, Oroville Dam, because they're concerned about the impact to the dam. And also in Utah, they're actually concerned about the potential rapid ice melt. And, even as recent as last weekend, there's several deaths in some of the rivers and creeks close by to here in the Bay Area because of the amount of water that's already coming from the snow melt. And folks are going in fully prepared to go rafting, but the current is way too strong and way too much water, and it's sucking people under and killing them immediately.
Oh,
so, yeah, it's happened in Yuba City and Yuba Lake or whatever. Yuba is the first thing that came to my mind, and then a couple other places close to here. So yeah, of course, it's undeniable. Yeah, so folks are getting sucked under because it's not because they're not being safe. It's because there's too much water and the current is too powerful. So yeah, and then okay, what impact is that going to make on the dam, etc.? And so that's why they're if you guys have seen maybe videos here and there of Oroville Dam, they're going nuts on fixing it as quickly as possible, and there's so much machinery there. So I don't report on it because YouTube will not allow you to monetize on any type of natural disasters or whatever. So it will automatically ping your video if you try to upload anything from the Department of Water Resources. So I just felt like I would just share that with everyone that, hey, if you're interested, go to their site or their YouTube channel. We can share the link, whatever. But they're racing. We'll just make it at that. Yeah. So we are concerned about that here for sure. Yeah.
Yeah. There's some weird things going on at YouTube that I've been discovering once again. I'm not even going to mention it on the air.
Yeah, we could talk about that later too, with some of the new creator rules, etc.
Oh no, I just happened to find out what they've finally done to my YouTube channels. And I just happened to find out through another truther channel. And he keyed me in on what to look for. And I did, and I found it, and I almost went through the roof. And now people in the country of Ireland aren't able to see our live streams anymore, from what I'm understanding.
Yeah, and I've got subs in Ireland, and I know you do too. That sucks.
Yeah, I just got those messages yesterday, and it just seems that the censorship wants to pour out again, and it seems like this woman over there in the UK. Ooh, I just like to pull her hair out. But ever since they had these two terrorist psyops over there, now they want to basically censor. Well, starting with YouTube, because they said that this had to do with YouTube and videos and terrorism and blah, blah, blah. And I think it's a bunch of horseshit.
Wow.
Yeah.
You can already see what route and direction that's going. Interesting.
Yes, sir.
That does not surprise me. Interesting timing too. Wow.
Yep. So that's why I've been thinking and thinking and thinking. And we need to put these things together and get out on the road. I mean, if we're really going to make a difference, then, you know, the hell with YouTube and let's get out on the road. You know, I was joking with the doctor yesterday. You know, I don't care if I have to get up on a stage like an evangelist. Praise Jesus, you're healed. I don't care if I'm going to walk out onto a stage with a boa constrictor around my neck. I want to fill a stadium, man. I want to have 75 to 100,000 people at Wembley. I want them to hear it. Yeah, they'll probably assassinate me right there. Sharpshooter. Yeah, get him right between the eyes. I want to take it to the road, man. I want to take it to the road. I want to take it to venues. I want people to see me, and I want people to see the doctor and see you. And I want people to see that we are real flesh and blood, and we are out there fighting for the damn truth, for disclosure on what the hell is going on. YouTube is just not going to cut it anymore. After what I found, I'm starting to get mad. After what I found out, what they've done to my YouTube channels purposely to stop the flow of information. Another truther channel, they just shut him down yesterday. He's from the UK. He got the dreaded message from YouTube that your channel's been terminated. And all he did was a report on the Manchester event.
I saw that video too, dude. That's really weird, man.
Yep. And he didn't do anything wrong.
Didn't do anything wrong, and they immediately terminated his account.
Yes. And he's been on YouTube for a long time, man. He's been on YouTube for a long time.
Russian vids referred to him, right?
Yep. Peaky May.
Yeah, exactly. So I never heard of the guy until yesterday. I saw the video, couldn't believe it. It's undeniable that there's censorship from YouTube, and it's coming hard and strong. Just for the fact that Google said, we are going to demonetize videos that we deem as fake news in April. And now they just rolled out with the new, from the creator blog, 3 new strike types of, community guideline strikes, or however you want to say it, 3 community guidelines, excuse me. Yep. And then exactly what you said about what I've been worried about, okay, is when is the day going to happen when someone goes nuts because of YouTube, and then it's all over the news, and they go, oh, we got to shut down YouTube.
Yeah.
Like that. And wow, it sounds like it started.
Yep. What are you going to do about that $750 million revenue loss now, you sons of bitches?
Dude.
And
I can only see only badness from this. Wow.
Yeah, what they did to Peaky May, they blew him out of the water over a 16-second video.
Yeah, it was ridiculous. It was concerning on all levels.
Yeah.
Like, whoa, dude, what just happened?
Yeah. And I mean, I watched he has a secondary channel, I guess. He got on there, Russian vids, gave him a voice, and he relayed the message, because they're all truthers. I think Russian vids, man, he's the best on YouTube, busting these psyops down. He picks them apart left and right, man. And I never miss an episode or a video of his. Never. People don't agree with his numerology and things of that nature, but there's a science behind it. And, listen, that science belongs with those nutcases over there that started the whole Illuminati crap. I'm going to get myself in trouble here too. I don't care.
I know we're going all over the place. I was going to mention the Bavarian Illuminati, but back to the PK guy. Like, I couldn't believe it. I can't believe that we talked about the same video and we saw it, and I couldn't believe that I could not believe that he got it taken down for that reason. I'm like, oh, no. What, you can't do or say anything? I mean, come on, man. How else can we report? I mean, I think people in the UK would be wanting to see any kind of news from a favorite YouTube channel they have. Like, let's say, you know, Scott or Chris or whatever. Hey, you know, there's been this, that, and the other. And people live there. Maybe they didn't know. Now, probably people's phones were lighting up, etc. However, a lot of times you go to social media and your favorite YouTube channel. So you get struck down for trying to report just basic news, and that's all he did.
Yeah, it's something else, man.
I agree.
It's running rampant.
Come on, man.
Yeah, it's running rampant across the entire globe. It started, you know, people talked a lot about this handing over of the internet back in October. Well, back in October, not soon after that occurred, that's when I saw all of my European subscribers disappear. They all just disappeared. They're still subscribed to my channel, but they can't see me. Switzerland, Bulgaria, Denmark, all of these countries.
Yeah, so when I was in Sweden last year, we would have to use a VPN, right, to trick YouTube into believing you were in a different country with a different IP address to allow you to view content on YouTube that was from America and from other countries. So that's not BS. There is active censorship happening from those countries.
Oh yeah, there's no doubt about it. Then you know, this is not the first time that I've heard from somebody from the UK or Ireland that told me, emailed me specifically and said, "Hey, listen, man, you know, I clicked on your live stream and it says not available in my country." What the?
Yeah, I can't believe that. That's wow. That sucks.
I mean, are we really talking about something that damn harmful? You're damn right we are. You're damn right.
Seconds.
We're throwing people under the bus. We're throwing the wrong people under the bus. And you know what? They're lucky I'm not driving the damn bus, because I would back the bus over. I'd back it up. I'd run you over once. I'd back right up over you, because this is all crap. Human lives all around the world. Hey, listen, man, you know, we know there's an issue. We know there's a huge issue. What are they going to do about it? They ain't going to do shit about it. What do they think? They're going to stop all of this? They're not going to stop anything.
No, just put us under martial law and we'll be fine.
Well, somebody just mentioned that they're getting a taste of martial law right now in the UK.
That sucks. Yeah. And so it almost looks like it's planned. You know, I don't know. I don't want to go there, but it's aggressive. And I understand where the aggression and the terrorism, et cetera, there's a lot of theories as to what's happening and who it's coming from. It's the CIA, it's ISIS, whatever. But at the end of the day, it is so strong that the reasoning to lock us down is very easily justifiable. And it's being done that way on purpose to make us feel and believe that our peace and security is far more important than our anonymity and our rights. So we will immediately give up rights like what's happening there in regards to our security, or what is perceived as our security. That's really scary, dude.
It is. It's very, very scary. And, you know, I was just thinking of something yesterday. And, you know, this goes all the way back to World War II. All the way back to World War II. And the United States government, they wanted to get into World War II. So what did they do? They had intelligence that the Japanese was coming across the Pacific in a huge fleet. And they let Pearl Harbor happen. Why? So they could get into the damn war. Same thing with 9/11. Those buildings didn't fall down. They were blown up, and not by jets, by demolition experts. They were seen in the damn buildings for weeks.
The crews that cleaned up the towers were specifically cleanup crews for controlled demolition events. Come on now. Let's stop lying to ourselves, boo.
You know, where do we go from there? We went into the whole Osama bin Laden crap.
I love
He's
it.
dead.
Oh no, SEAL Team 6 took him out.
And then they killed all of them.
Yeah. The lies. I love it. Yes, we got a lot going on.
Somebody just told me the other day that they were down on Miami Beach and they saw Osama bin Laden sitting there having a Mai Tai with Michael Jackson. I'm just joking. But, you know, the thing about World War II is, okay, technology wasn't at its peak. But as bad as the Third Reich was, and these Nazis running all over Europe, we took them out. So how in the hell is it with modern day technology in warfare that we can't take out this little dumb group, ISIS? I don't believe it. I think that this whole charade is just that. It is a whole entire charade to scare the living daylights out of the world populations about this so-called crap terrorism. What the biggest cover story would be in order to invoke and militarize police departments, countries, and get it all prepped and ready when they got to turn the switch. I'm really getting mad. I'm serious. This is really ticking me off because I know I can feel it. I know it. I can feel it in my bones. I've been watching this stuff for 20 years now. And they're just taking it to other levels. Horrible levels. And they think they're going to get away with it. But the bottom line is, man, we're letting them do it. The dumbing down of the whole entire world. It's happening. People got their heads in the clouds, man. They don't care. Like people say, oh, you know, Scott, I tried to tell my family about this, but they think I'm crazy. Okay, well, you know what? I know you love your family, but if you can't steer them in the right direction, then you have to save your butt. I love my friends. I love my family. Okay, whatever. If I can't steer them in the right direction to jump on board with me, then so be it. I can't do anything about it. But just like I've said before, and I will say it again, and I will end this broadcast with my statement. And when I go down, man, I'm going down in a blaze of freaking glory. And I will go to my grave knowing wholeheartedly that I did every damn thing that I could to bring the word out and tell people about what is happening. I can't help it that I don't have the most top-notch scientific evidence because they're hiding it all. And we're doing our damnedest to bring it out. But I will go to my grave and I will rest in peace, knowing that I did everything that I can do. And guess what? I'm not done. And neither is Chris Potter and neither is the doctor. We're not done. And if I have to take this to the road and tour this whole damn country and wherever else it may take me, I will find the money. I will find the means, and you can guarantee I'll be in a city where you're living. And I don't care if I have to stand in a park and hold an outing in a city park somewhere. But I can guarantee you that I will have people listening to me. That much is a fact. What's that song that Nelly came out with? It's getting hot in here. Whoa. Yeah, and I'm going down in a blaze of glory. Yeah, I'll sing it all the way to my grave. I'm not afraid. Chris, I know you're not afraid, and I know the doctor's not afraid. That's why we're here. I'm getting fired up, man. I could actually feel my heart inside of my chest quivering whenever I talk about these subjects, because they think we're a bunch of damn fools, and we're not. Man, I'm fired up now. I might go find me a politician and just kick him right in the nuts right now. Anyways, how do you feel, sir? What do you think about the situation?
Well, all right, just looking real quickly, because I know we're going to wrap things up. Looking at NASA's site on climate change and weather.com, they have graphs that show the amount of weather patterns that have increased and climate change increase and what's called, global warming. And they put it in a scale form over the last 200 years, and it freaking goes through the roof over the last 20 years, period, the end. So come on. Is it okay? And then we can start talking about Dane Wigington, geoengineering.org. He, in his research with his ex-NASA engineer, who's an anonymous individual, is basically saying we've only got 10 years left because the ozone is going. Why? Why is the ozone going? Is it because of chlorofluorocarbons? Is it because of cow farts? Come on! At what point do we have to say, come on now, this is BS, what's happening? Now, when it gets into the whole Planet X Nibiru Hubarculus, blah, 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 whatever, right? The brown dwarf Nibiru, whatever you want to call this thing, okay? There's something that comes into our solar system. Come on, let's talk about it. And certain things start happening in the solar system and to the Earth in regards to weather patterns, St. Cole's math out, and blah, 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 right? Come on, we can just repeat it over and over and over again. So, okay, if it's not that, then what's going on? Because it's on NASA's website. I know that some of us don't even believe NASA, but why are we going to contest the fact that even NASA says the weather patterns have increased dramatically, severely over the last 20 years? It's given on one of our 100, 200-year scale. So, I mean, I think that that's evidence that should be strongly considered. Okay, now if the ozone is failing, and it's not because of the sun, that's what Dane's argument is, and they're chemtrailing geoengineering, then what's going on the Earth? What's happening? Did we kill it? Right? On top of whatever's happening in space? So we're getting a double whammy? I actually think that's what's happening. Personally, I think we have two things going on. I don't know, but it's undeniable that we've got problems and they're spraying and something's wrong. And then we've got people making videos that aren't the physicists, that are Mr. MBB 333 and BP Earthwatch, that are talking about UVC A, B, C, and to watch out and make sure that you have sunscreen. I never gave a rat's about sunscreen till I had skin cancer on my back removed 4 months ago. Yeah, so what's going on? What's happening? It's undeniable. Something's going on. We can't just sit there and ignore it. And that's my thought on it. And I don't think there's a conspiracy. It's just a matter of what it is. That's where it gets, that's where people get, really sensitive and emotional, is what it is exactly. What's wrong? I think we're on to something. I think we're on to something significant. I think Dane's on to something significant. Why even bring up his research? Because just the last week, the physicists had put out a document about the UVC. And then this NASA engineer, ex-NASA engineer that was anonymous that worked with Dane, said the same thing. And he's all freaked out. And I was like, whoa, dude, why do we keep paralleling one another? And even in, we'll say, the community on either side of the coin, where we continue to parallel one another's work in an odd way. So I just would have to say something's happening. We would be foolish to ignore the signs that appear to be around us. And again, even folks, you know, that don't believe in NASA, we actually should be looking at NASA and some of the research, because it appears to be that, you know, they're telling us something's going on. And I think a lot of us are just putting our heads in the sand. Anyway, that's all I have to say.
Yep. No, I agree with you. I agree 100%. You know, we're going to keep on keeping on. That's the new saying. We're going to keep on keeping on. We're going to keep doing what we're doing. I do want to take it to another level. I think everybody in this entire world, I think they deserve it. I don't think I'll ever be able to cover the entire world like I want to. But I know one thing. I have access to the United States. I have access to 48 states. I have access to Mexico. And I know you get me out there beating my drum and beating my chest. You give me a crowd of 50,000, 75,000 people. They'll put a bullet in my head. I can guarantee you that. There ain't no doubt about it. They'll shut me up 1, 2, 3. But you know what? Like I said, I'll go to my grave knowing that I did everything possible. And then I will come back and I will haunt the living shit out of every one of these scumbag elite till they piss their pants in their sleep.
Sounds good.
Yeah. Doctor, once again.
Yes, Scott?
Any last words?
Well, thank you again for having me, for allowing me to speak the truth. Even though the powers that be do not like it. And I would like to end by saying that it is time to get to know our Creator.
There's going to be some of these people that are going to meet their Creator. You know, in more ways than one. And I'd love to see the look on their face when they stand in front of the God Almighty and they say, "Oh, I'm so sorry. I'm so sorry, Father. I did wrong. Will you please take me into heaven?" Well, see, they're going to be very lucky that I'm not God, because I would slap them right back down to hell. Ooh, I mean, I'd slap them so hard their head would spin around like that little chick in The Exorcist. Anywho, anyhow, and anyway, ladies and gentlemen, it has been a pleasure having all of you with us today. I think we had a pretty good rant at the end. I haven't had one of those for quite a while. You get me on a roll talking about some of these subjects, I'll sit here for 8, 10, 12, 24 hours. I'll stay on here till YouTube pulls the plug. But the bottom line is we have our own agenda. Our own agenda. Our agenda is not to disinform anyone. Our agenda is to inform you of what's happening. And I know a lot of people that have been frequenting the live chats in the live stream are starting to refer to each other as, "Hey, welcome to our family. Welcome to our live chat family." I appreciate that. I applaud that, because in the long run, that's all that we're going to have. You know, when things get bad, really, really bad, you may be standing next to someone that you've never seen in your entire life. And you may need help. And hopefully that person helps you. And then in turn, you pay them back by helping them when in need. And that's what we're all doing here. You're helping me. We're helping all of you. And together, hey, we're doing our thing. We're listening. We're investigating. We're researching. We're spreading the word. We're doing the best that we can. But I appreciate each and every one of you being with us each and every day. Believe me, if I had you all here, I'd give you all, a big Italian hug and say thank you. We'll be back tomorrow with another topic, more information. That much you can guarantee. So make sure you stay tuned. This is Scott from Planet X News. Thank you for watching.